We're going to talk today. This is just 6.3. We're going to do 6.3 part 1 today, 6.3 part 2 tomorrow. Then we're going to practice Wednesday, Thursday. Your quiz is going to be Friday. We are talking about trig functions again, but now we're not going to be talking about SOHCAHTOA. We're going to be talking about finding value of sine, cosine, tangent, and the reciprocals for any angle on the unit circle or not on the unit circle. So you guys are used to this picture here, right? I have my right triangle. They told me theta, which is where I'm looking. They're telling me the angle that I'm referencing. So in looking at theta, the side across from the right angle is always the hypotenuse, right? The side that's touching theta is the adjacent, and across from theta is opposite. You guys are used to that. Now we're going to be thinking of it like on an XY chart. You're always going to be thinking that your theta is at the origin. So the legs of your triangle, right? The A and the B, if you had A squared plus B squared, the A and the B are going to always be referenced along the x-axis and the y-axis. Everybody understand that? You see what I mean? So when I have A squared plus B squared equals C squared, that's the same thing as saying, with this picture, x squared plus y squared equals what? R squared. In this case, whenever you talk about R is going to be your hypotenuse. What do you know that R is always going to be? What kind of a number? Not necessarily a perfect square, but it's always going to be what? Positive. Always going to be positive. That's really, really, really important to remember. R is always positive. Because think about this. On an XY chart, if I went from here at the origin and I went left, what's my x value going to be? Positive or negative? Negative. And then if I went down from there, what's my y value going to be? Negative. So just remember, you have to remember with the quadrants, what's negative, what's positive. And we'll talk about this a little more. It's not bad, I promise. What I just said to you is right here. If you're trying to find R, you take both of the legs, add them together, square them, add them together, take the square root. It's the same thing as A squared plus B squared equals C squared. It's just using a different lettering system. This is super, super, super important for you guys to memorize. Super duper important. I'm going to ask you this a million times. A million times. Sine is the y value over r. It's whatever you go up and down, the y, the up and down, over the hypotenuse. Cosine is the x, whatever you go left and right, over the hypotenuse. Tangent is y over x. You guys need to remember that. So if I asked you what the reciprocal would be, the sine reciprocal is cosecant. What would the reciprocal be? R over y. Good. For here, secant of theta would be r over x. Good. Cotangent of theta would be x over... Yep. You just flip it. Whoops. Whoa. That got tiny. So here's a picture. Does everybody understand what the quadrants are? This is quadrant what? 1. What are the signs in quadrant 1? Your x and your y. Positive and positive. Right and up is positive, positive. Over here is quadrant what? 2. What are my signs for quadrant 2? Negative, positive. Down here in the bottom left is quadrant 3, and it's what? Negative, negative. Good. And over here to the right is quadrant, and it's positive, negative. Quadrant 4. Important to remember that, guys. Okay, we're going to talk about something called reference angles. You'll see in a second. It's not that bad, I promise. We're going to use reference angles to solve stuff. So we'll look at that in a second. This is just what I just told you. Our 6 trig functions. Let an angle in standard position. All that means is it starts right here on the x-axis, that's standard position. If it's a positive angle, we measure upwards. If it's a negative angle, we measure down. And you just use the x value and the y value to find the R value. I'll show you. It's super easy, but you guys need to memorize these ratios. You need to know that when I say cosine, x over r. When I say cotangent, you say, well, x over y. You need to know those things. So make you guys get that. Okay, reference angle. It says let theta, an angle in standard position, the reference angle associated with the angles in the acute angle form of the terminal side of the x-axis. I'm going to give you some little points here. When we're talking about reference angles, if you had me for pre-calc, we talked about this. When an angle is given to you in quadrant 1, okay, the angle that they give you equals the reference angle. If your angle is in quadrant 1, the angle they give you equals the reference angle. I'll talk to you about what that means in a second. If they give you an angle in quadrant 2, okay, the angle's in quadrant 2. In order to find the reference angle, you're going to say 180 minus the angle they give you. That's going to be your reference angle. If they give you an angle in quadrant 3, okay, quadrant 3 angle, to find the reference angle, it would be the angle that they give you minus 180. That equals your reference angle. And I'll put this into numbers in a second. Quadrant 4 angle, if that's what they give you, you're going to say to find the reference, 360 minus the angle they give you will give you your reference angle. Mm-hmm. There's two things that are super, super, super important that will help you identify what the reference angle is. And if you can remember these two things, it'll be super helpful, I promise. Reference angles are always acute. What does the word mean? Acute. Less than 90. And they'll always be positive. They will always be acute and less than 90. So let's say they said to me, given the angle, let's do some. Here, let's do these examples. This is how you find reference angles. Okay, 87 degrees. If I were to give you a picture of what an angle looks like 87 degrees, what quadrant is 87 degrees? It's in quadrant 1. Quadrant 1, okay? So your angle would be something like this, whatever, right there. Your reference angle, by definition, is the angle formed from the terminal side of the angle down to the x-axis. So I would draw like this. It'd be right in here. Guys, quadrant 1, what is the rule for quadrant 1 that I told you? Okay, it's always acute, it's always positive, but what's the rule? What did I write? What did you guys write? Reference angle.
Theta equals.
So the angle they give you equals what? The reference angle. So the reference angle, anything in quadrant 1, is whatever the angle is given. Because the reference angle always has to be two things. What and what?
Positive.
Acute and positive. Is 87 acute? Yes. Is it positive?
Yes.
You're good to go. If they give you this angle, 197, that means it starts here. Guys, think about this. This is 0, 90, 180, 270. So the first thing you need to do, good, Borja, is where is 197? What quadrant?
Third.
It's in the third, somewhere over here, right?
Yeah.
Quadrant 3. If you were to draw the reference angle, it's from the terminal side to the x-axis. So it would be right here. What is the rule for quadrant 3? The angle that they give you minus 180. So the angle they give me was 197 minus 180 equals what? 17 degrees. Check. Is that number positive?
Yes.
Is it acute?
Yes.
So you're good to go. So here's a way that you guys can remember, oh, I don't know if it's 180 or, because look, you only use 180 or 360, right? You don't use 90, 270 in the rules. So say you forget, and you're like, wait, was it 180 minus or the angle minus 180? Look, if I say 180 minus 197, what kind of an answer do I get? Negative. I get negative 17. Well, what is the rule for reference angles? They have to be what and what? Positive and, so that doesn't work. What if you say, oh, wait, should it be 360? Well, what's 360 minus 197? It's more than acute, right? It's more than 90, so that doesn't work. So that's a good way to check yourself. If you guys are like, I can't figure out what, just use the 2 key points. Acute, positive. Yes, sir?
Wait a minute, why did you put, what if you put the arrow on the other side?
What do you mean?
How do you know to put it there if it's like on this side, but not on this side?
Because it's in between 180 and 270.
Oh yeah. Okay.
Like 240. Think about this. Thank you, sir.
Thank you.
All right, I have 0, 90, 180, 270.
So I'll go inside then.
It goes in which quadrant?
Quadrant 3.
It's going to be over here in quadrant 3. I don't know exactly where, but it's going to be over there. So what's the rule for quadrant 3? The angle minus 180. So 240 minus 180 is 60 degrees. Check. Is that acute and positive? Yes. Okay. What about 135? Well, if you don't know, draw yourself a quick little picture. Draw yourself a quick little picture. Where is 135? In between what two numbers? 90 and 180, right? Somewhere in here? So your reference angle, if I drew it, would be from the terminal side down to the x-axis. What's the rule when you're in quadrant 2? 180 minus the angle that they gave us. What's 180 minus 135? 45 degrees. Is that positive and acute? Yes. So reference angles aren't really that hard. You just got to remember, you don't even really have to remember the rules per se. You just have to remember that they have to be what? 2 things. Positive and acute. So if you use 180 and 360, you'll figure out which they should be.
For the last one, how come for 197, how come you didn't use 270?
You don't use 90 or 270. You always use 180 and 360. That's a good question because reference angles are drawn to the x-axis, not to the y. So that's why. Good job. Good question. All right, you guys okay? All right, now find the reference angles for, okay? They gave us a picture here, which is really nice. But I don't really care that they gave us a picture because I'm not going to give you a picture. You're going to have to figure out what quadrant the angle's in. So let's pretend that the picture's not there. Guys, do you know where 5 pi over 3 is?
Your calculator is.
No, I don't know offhand though, like just by looking at it. How could I put this into terms that would make me think a little easier of where this is? I can change it to degrees. Let's do that. Right? So pi's cancel out. How many times is 3 going to 180? Yep, 3 goes into 3 once. 3 goes into 180 how many times? 60. So I have 5 times 60 is 300. Okay, again, I don't care about a picture. Where is 300? 0, 90, 180, 270. This is also 360. So where is where is 300? It's over here somewhere. Okay, so if I drew my reference angle, it would go from the terminal side to the x-axis. What's the rule, guys? 360 minus the angle that they gave us, which is 60 degrees. There's your reference angle. I have one more step I'd rather you do, though. Put it back in radians. How come? We started in radians. Let's end up in radians. So I'm going to go backwards. So my zeros cancel out, right? 6 and 18. What goes into both? Okay, 6 goes into 6 one time. 6 goes into 18. So my reference angle would be pi over 3. Nunez, question. All right, let's look at the next one. What do you guys notice about 870? It's bigger than what? 360. Once you guys see that it's bigger than a whole circle, you don't need to freak out. Let's just keep subtracting a whole circle till we get what? Coterminal. Good, I like that. Something that's in between 0 and 360. So let's minus a whole circle. And I get what? 510? Is that less than 360? Okay, so let's minus a whole circle again. 150? You guys with me? Okay, is that in between 0 and 360? Okay. So I'm going to give myself a little picture. $150. It's going to be in between which two numbers?
91.
Good, 9180, so somewhere over there. So if I drew my reference angle, it would be from the terminal side down to the x-axis. What am I going to do to figure out the reference angle of 150? 180 minus 150, and I get 30 what? Is that number acute?
Yeah.
Is it positive? We're good to go. Again, if you forget and you say, is it 360 minus or that angle minus 180, something like that, you guys have to make sure that you remember the two things. It's acute and positive. And you only use 180 and 360. Borja just asked that question. That's a very good question. The reason why we only use 180 and 360 is because we're drawing your reference angle from the terminal side where the angle ends to the x-axis, not the y. Yes, sir?
On a quiz, like, do you have to be like that? Or, like,
No.
Okay.
I just do that to draw a picture. Okay. This is going to be very important for you guys to remember. All right, we're going to talk about the signs, meaning positive or negative, of all of our trig functions. You need to remember this right here. In the first quadrant, remind me again what the signs are in first quadrant.
Sine, cosine, tangent.
But what are the signs, like negative and positive? Positive, positive, right? Every single trig function we talk about, all 6 of them, if the angle lies in the first quadrant, they're positive. In the second quadrant, what are the signs? Negative, positive. The only thing that's positive, the only trig functions that are positive are sine and its reciprocal, which is cosecant. Everything else is going to be negative. Here, tangent is what? Negative, negative. So the only thing that's positive here is tangent and cotangent. Because think, x over y, if you divide a negative divided by a negative, you get a what? Positive, okay? And then over here in the fourth quadrant, what are my signs? Positive, negative. The only thing that's positive is cosine and its reciprocal, which is secant. So the way that you can remember this, like please excuse my dear Aunt Sally, is all students take calculus. Now, let's see why this is important for us now. All right, when we evaluate trig functions at any angle, you're going to find the reference angle, determine the sign, positive or negative, of the functions, and then you're going to evaluate all the functions. So, look at this. Cosine of 135. This is why this is important. If I say to you, it says find the exact value of the trig functions, I want to know, cosine 135. Okay? Don't even look at that picture. There's a lot of information here just by telling you the angle that they're talking about. First of all, cosine. With our trig functions, cosine is what over what? No, not that. X, Y, and R. I want you to use X, Y, and R. Cosine is X over R. Okay, we've got to remember that. When I talk about the angle 135, where is 135? God bless you. Look, this is what's important. X over R. Where is 135 if I were to draw it? It's in the second quadrant. It's in quadrant 2. What do you know about the signs of x and y in quadrant 2? It's negative, positive. That means your x value is what? Negative. And your y value is positive, right? Does everybody understand that? We okay? Yes? Okay. So what is our reference angle? What is our reference angle for 135?
45.
It's 180 minus 135, which gives me 45 degrees. Okay, I'm going to do this, guys, without, I don't want to use reference angles. I'd rather use the unit circle. We'll give you the unit circle. Well, not that it's going to make it any easier for you, but if you are talking about the angle 135,
Wait, so no reference angles?
I mean, not that we're not going to do reference angles, but we're going to solve this without, yeah. Because is 135 on the unit circle? Well, the one that I pulled, obviously. Okay, guys, here we are. Where is 135 on the unit circle? Tell me what the x and y is. Negative root 2 over 2 and positive root 2 over 2. You guys see it right here? Everybody see that? 135. Nunez, you see that? Ryan, you see that? Okay, so if we have 135 is negative root 2 over 2, positive root 2 over 2. Right? Cosine is our x value. Sine is our y value, if it's on the unit circle. If it's not on the unit circle, we'll figure something else out. I'll show you that in a minute. But cosine is our x value. What is the cosine? What is the x value of 135 degrees? Negative root 2 over 2. If I asked you what the sine value is, you would tell me what?
Root 2.
Positive root 2 over 2. It's the y. And then if I asked you for the tangent, you would do y over x.
How do you know if it's like?
X is cosine. Y is sine. That's the value that's there.
Right.
If it's on the unit circle. If I said to you what the tangent, you guys would tell me it's y over x.
Oh.
Before you start freaking out, like it's root 2 over 2 divided by root. It's the same thing, right? What's anything divided by itself? 1. And since there's one negative and one positive, it would be what kind of a 1? There you go. All right. When you would have to use reference angles is when the angle that's given is not on the unit circle. Is 390 degrees on the unit circle? No. But can you figure out the reference angle to that? Yeah, let's take away one whole circle. What do I get? 30 degrees. So guys, 30 degrees. Find 30 degrees on the unit circle. What's the ordered pair at 30 degrees? What's the ordered pair? Root 3 over 2. It's root 3 over 2, comma, what was it, 1/2? 30 degrees, yep, comma 1/2. All right, so look, if I asked you, ladies and gents, if I asked you what the sine of 30 degrees is, sine is what value, x or y? Sine is y, so sine would be 1/2. If I asked you what the cosine was, you would tell me it's what? X value, which is root 3 over 2. What are they asking for here? The tangent of 390. So tangent of 390, same as 30 degrees, is what over what? What's tangent? Look back at your notes. What's tangent? What over what? Okay, but with our x, y's, and r's. Tangent. Y over x. So what is the y value of this ordered pair? 1/2 divided by, what's the x value? Root 3 over 2. Guys, you had to divide fractions? Keep, change. So 1/2 times, when I have root 3 over 2, when I flip it, it becomes 2 over root 3, right? Yes or no? What happens to my 2's? So I'm left with 1 over root 3. Am I allowed to have that? What do I have to do? I gotta rationalize. So my answer is root 3 over 3. That's the most math you guys are going to have to do is something like that. And again, I know some of you are like, what? It's okay. We're going to finish this up tomorrow, and then we're going to practice Wednesday and Thursday because you guys got to wrap your head around this. Let's look at this. Find the exact value of the trig functions. All right, let's put in our unit circle. Let's remind ourselves, we want sine is what value? Sine is x, y, what? Tell me, don't leave and look at the unit circle yet. What is sine? What value? X or y? It's the y value. We need to memorize that. It's also y over r if we're not on the unit circle. But is there 240? Do I have an ordered pair at 240? What is it?
4, negative 1.
Negative 1/2 and negative root 3 over 2. So if they ask for the sine of 240, sine is what value again? The y value. What is the y value in this ordered pair? Negative root 3 over 2. If I asked you for the cosine, you would tell me it's what? Negative 1/2. You guys need to know what letters represent what. All right, let's look here. Cotangent of 495. Well, the first thing I need to do is what?
See if it's X or Y.
Not yet. 495. Is that on my unit circle? No. So subtract 360. 9 minus 6 is 4, right? 9 minus 6 is 3. Thank you. Is 135 degrees on my unit circle? Is it? Okay. What's the ordered pair at 135? What was it? Negative root 2 over 2 and positive root 2 over 2. So negative root 2 over 2, positive root 2 over 2. Now look back at your notes. Cotangent. What is cotangent? What over what? It's x over y. So take the x value. What is the x value? Negative root 2 over 2 divided by the y value, root 2 over 2. Fraction, guys, keep change. Negative root 2 over 2 times positive 2 over root 2. What happens to my 2's? Cancel out. What happens to my, what is it, Ryan? Negative 1. Perfect. Yeah, because it's the same thing divided by itself. We're going to practice this a lot, but you guys have got to get those trig ratios memorized. What do you think I should do here first? Do you guys know where 16 pi over 3 is on the unit circle? So what should I do? Change it to what? Let's change it to degrees first so we can find it. Pi's cancel out. 3 goes into 3 once. 3 goes into 180 60 times, right? Everybody tell me real quick what 60 times 16 is, please. 960. Is that on the unit circle? No. What should we do? Let's subtract 360. So minus 360, I get what? 600. Okay, then what? Minus 360 again. What is it? 240. Is 240 on the unit circle? Yep, it sure is. What is the ordered pair at 240? You guys don't have a unit circle, do you? What's the ordered pair at 240 degrees? Look at it. Negative 1/2. Negative root 3 over 2. So it's negative, negative 1/2, negative root 3 over 2. Yes? Okay, so I'm asking you guys for the sign. Which value is the sign? The y. So it's negative root 3 over 2. There's not a lot of math involved here computation-wise. Lots of thinking. Some of you are better than that than others. The last one I'm going to look at is negative pi over 4. This is how we find our negatives. All right? Negative pi over 4. Where is positive pi over 4? Do you guys see it? I start here and I go up. How many spaces? 2. So if it's negative, how do you think I find the ordered pair I'm looking at? Start here and go down. How many? 2. So this is the ordered pair I'm looking at. Root 2 over 2, comma negative root 2 over 2. And they're asking for the secant. Oh, geez. Secant is what? Secant is the reciprocal to...
Or what?
No, cosine. You're right. Cosine is what value? X. So secant would be what?
Y.
No.
R.
Wait, R?
What's the reciprocal? 1 over x. Good. Very good. So I'm going to say 1 over root 2 over 2. Keep, change, flip. 1 times 2 over root 2. I get 2 over root 2. Can I have that? No. I have to rationalize, right? So I get 2 root 2 over 2. What happens? The 2's cancel. I'm left with just root 2. Lots of canceling and thinking and figuring and moving and all that sort of thing. But you guys, you'll be okay, I promise. We'll practice this a bunch. A bunch. We all right? A little bit? A little bit okay?